This micro-credential deals with troubleshooting methods and consists of 5 targeted skills. This targeted skill is about bottom-up approach to troubleshooting. There are 3 different approaches for using the Open Systems Interconnection OSI model in troubleshooting. One is the bottom-up approach. It starts the process at layer 1, the physical layer of the OSI model, and works up through each of the layers until the problem has been identified. The physical layer deals with the physical aspects of the network, including the power necessary for the devices to operate, the media such as copper, fiber optic, and wireless, and encoding the information for transmission across the media. Technicians should begin by ensuring that the devices are receiving power. Although this seems too simplistic a solution, sometimes simple is the answer. Although it might be easy to determine whether or not an end device has power, connectivity devices like switches and routers are often hidden away in a wiring closet or above a suspended ceiling. A trip breaker or a bad power supply may go unnoticed for an extended period of time. When a work group switches the problem, it will normally affect more than one device. The larger scope will indicate that a connectivity device such as a switch or router may be the issue. The technician should also inspect any physical media to ensure that it is properly connected to the network interface cards, NIC, of the device and the port of the switch. The media should also be checked for any physical damage as well as being the correct type and configuration for the intended use. Different types of physical damage can occur. A scarred or damaged outer jacket on a cable is easily recognizable. A cable may need to be closely inspected to see if it is crushed or flattened. A network cable tester can be used to confirm damage to a cable. Even if there is a lack of physical damage, it is a good idea to test the media to rule it out as a problem. Another way technicians can check physical connections is through the use of link or activity lights, light-emitting diodes, LEDs, on the NICs and connectivity devices. If these LEDs are green and flashing, it indicates that there is an active network connection and frames are being sent and received at the full speed of the connection. An amber or yellow light still indicates an active connection, although it is probably not operating at full speed. Another physical layer problem technicians may encounter is equipment failure. Networking components fail over time and may not give any outward appearance of the failure. When a technician suspects failure of a device, substituting a known good device for the suspected device will help to confirm or rule out the problem. In the bottom-up approach, when a technician has exhausted the Layer 1 possibilities, they move up the OSI model to Layer 2, the data link layer. This layer is responsible for media access control, MAC addressing, as well as error detection and frames. MAC addresses are 48-bit addresses written as 12 hexadecimal digits. These addresses are programmed into the read-only memory ROM of the NIC by the manufacturer and are used to identify a particular device on a network. Both the destination and source MAC addresses are required for the transmission of frames on a network. No 2 devices should ever have the same MAC address. The original MAC address of a device cannot be changed. However, software can be used to anonymize that device or spoof the MAC address of another device. If duplication occurs, it generates an error that prevents both devices from transmitting data. Switches are Layer 2 devices capable of reading and using MAC addresses. These addresses are used to make forwarding decisions and for security. MAC address filtering can be used to block specific MAC addresses from having access, and improper configurations can also block the wrong device. Configurations can be checked through the device's command line or web interface. Another Layer 2 problem involving switches is virtual local area networks, or VLAN misconfigurations. They are used to segment networks into different broadcast domains for both security and performance. VLANs use frame tagging to enable communication within VLANs and VLAN routing to control traffic between VLANs. Configuration errors can cause devices or switch ports to be associated with the wrong VLAN and interfere with communication. Modern network interface cards, NICs, and switches use auto speed and duplex to automatically adjust to the criteria of the networks they connect to. However, if a user tinkers with the speed and duplex settings on a network card, this could result in problems. This can be checked in the Ethernet properties of the NIC. When a technician has exhausted all the possible Layer 2 problems, they should continue troubleshooting problems in the next successive layer until they discover and resolve the problem. The bottom-up approach is one of 3 approaches in the Open Systems Interconnection model for troubleshooting. Steps to follow using this method were discussed in this micro-credential.